These notes for Honors Math 3. This is 7.5 on solving logarithmic equations. And to start, we're going to go through the two types of logarithmic equations that we'll run into, which you've seen a little bit of in Objective 3, I think, maybe Objective 4 as well. And so those two types are one equation that has all logs, where every term is a log on either side of the equation. And then the other is called sum logs, which means you have a mixture of log terms and then some constants. And so these are the ways that we'll go about solving these two things. If we have an equation with all logs, what we want to do is simplify each side to only one log expression. And you'll do this by using your different formulas, rules, properties that we've been through so that we can evaluate more easily. So simplify each side to one log expression by combining them. Once we do that, each side is a log expression. So using this property will undo those logs, and what happens, we get to set the two sides equal and solve. If we run into an equation that only has sum logs, which is a mixture of logs and constants, we'll separate the log terms to one side, the non-log terms or the constants to the other side of the equal sign. We want to combine all the logs on the side of the equal sign where we gathered them. So similar to what we do with all logs, simplify all the logs into one. And then we'll take it out of log form and into exponential form, and we'll solve that way. So those are the two types. And so I'm going to go through a couple examples with you. These are some problems from your homework. So the first example is problem number 2 on your worksheet. And so you can see this first one has all logs. Every term is a log. And so we're going to look at solving it that way by simplifying each side to one log expression. So I can leave the log here, I can leave these logs here, but I'd like to combine and simplify. And I don't want to end up with any coefficients. So I'm going to be using my power rule, which told me power can become a coefficient. So we'll work backwards with that. We'll take our coefficient here, and we want to rewrite it as our exponent. So this 1/2 is the power of 4. We'll do the same on the right side. This 1/2 is the power of 2x minus 3. So to combine the two logs on the left, we're going to use our quotient to difference property, but backwards. So difference between two logs back to the quotient. So we have the same log base 7, inside of which the first term stays in the numerator. Anything following the negative sign will move to the denominator. So we want to divide by 4 to the 1/2, or square root 4, which is 2. On the right side, we'll just rewrite this right now as log base 7 of the square root of 2x minus 3. So once I'm down to one log expression on each side, I can use this log property, and that was the second log property that I introduced back in, I believe, Objective 3. And so because we have these logs, remember a log is just a mathematical operation, taking log of both sides, we might as well undo the log on both sides. That property, so we just want to introduce a base of 7 on each side, just like this. And now this property will simplify each side. So the 7 to the power log base 7 of whatever's inside is what it will simplify to. So that means on the left here, this simplifies to just x divided by 2. And on the right side, it simplifies to just root 2x minus 3. And so this is the equation that we're left with to solve. And so we do want to solve for x, but there's an x on both sides, so we'll square both sides. So I have x squared over 4 equals 2x minus 3. Maybe we'll multiply 4 over. X squared is equal to 8x minus 12. We have a quadratic equation. We'll get everything on the same side. And see if we have some factors here. So factors of 12 that will add up to negative 8. Looks like that will work. And so I have potential solutions 6 and 2. The only thing is I want to make sure that these are solutions that will work in my original equation. Remember, logs do have some values that won't work. The biggest thing you want to remember is since x is the value inside of the log, we can't take the log of a negative. So it looks like as long as I can plug in 6 and 2, right here, they're both positive. The only other place would be over here. Plugging in 6, you'll definitely get a positive. Plugging in 2, you'll end up with 1, and that's fine. Log of 1 is 0, so that would work out just fine as well. And so these are both solutions to this example. So the next problem from your worksheet is number 8. And this one is just natural logs, which means we are working with a base of e. You'll notice that 2 of the terms have a log and 1 of them does not. So this is definitely a sum logs problem that we're doing. We would separate our log terms on one side of the equal sign, the constant to the other, and that's already done here. So we're going to go on to the next step, simplify or combine all of the logs. So on the left side, we want to combine those logs. In order to do that, and I'm going to remind you, sum logs. Really, we just need to start by moving our 5 coefficient back up as the power here. So just like we were doing in example 2. And then I'm going to simplify that. So this is now the natural log of e to the 5th divided by 2 plus natural log of x is equal to 1. In order to combine these, we're going to use our product to sum rule and working backwards with that to simplify it. So sum back to a product. So I have logs with the same base, just like I did last time. So these are both natural logs or logs with base e. Inside the first one, I already have e to the 5th over 2. You're not going to do anything different with that. Anything that follows here, the addition sign, the x is going to multiply. So in other words, we're going to leave it in the numerator. So times x, or you can write it right next to e to the 5th. All right, so we've simplified and combined all of our log terms, and now we want to rewrite it in exponent form to solve. So to do that, remember we can use our log loop that I showed you last week. We're going to start with knowing that a natural log has a base of e. We take e to the power 1 is equal to all the stuff inside. So we're going to write e to the power 1, which is just e, is equal to all this inside, e to the 5th divided by 2 times x. To solve for x, you want to divide by your coefficient or multiply by its reciprocal. In this case, we're going to multiply both sides by 2 over e to the 5th power. All right, so from that you can reduce the 2's on the right, the e over 5, e to the 5th as well. You're left with your x value here. On the left side, we'll reduce our e values. So 1e with 1 from the denominator leaves you with 4 of them. So 2 over e to the 4th. And that is an exact answer. Without a calculator, you wouldn't give a decimal approximation unless you were asked for it. And if you were asked for it, remember it's always to approximate to the thousandths place. So we have one more example from this worksheet we're going to do. This is number 28. And just a note, if you ever see things like log 1 or something that will simplify, you might as well do that so that you can simplify the equation more before you get started. So in this problem, you really do just have one log on each side. We just need to clean up any coefficients. So this is an all log problem. So just like problem number 2. And so we'll take that negative coefficient, we'll rewrite it as the power of 30. So a power of -1 is going to change that 30 into a 1 over 30. So I'm going to rewrite this. And then we have one log on each side. So we're told second step is to use the log property of introducing a base of 5 to each side. And this property tells us that we do that because that was the base of the log. And the property now allows us to reduce the left side to just what's inside of the log. So 1 over x minus 1 over x plus 1. And on the right, we just simplify to 1 over 30. All right, so we have this rational equation. We're going to simplify it so it's not rational anymore. We want to multiply through by the least common denominator. So we're going to multiply everywhere by x, x plus 1, and 30, since that's my least common denominator. All right, so on the left side, when I distribute this in, the x's will reduce, and you're left with 30 times x plus 1 times 1, so 30 times x plus 1. Distributing to the second term, the x plus 1's will reduce, and so we're left with 30 times x times -1, so minus 30x. On the right side, only the 30's reduce, 1 times x plus 1. All right, and so we'll work this out. And here we're looking for factors of -30. That will add up to 1, and it looks like that will work. So we've got x plus 6 and x minus 5. And so potential solutions are -6 and 5. So remember that these are solutions to the quadratic equation that I just solved. We want to know if there's solutions to our log equation. So don't assume that just because you have a negative number, you're going to throw it out. It really depends on what's going on inside the log. And there's a lot of stuff happening here. So I just want to simplify the stuff inside and make sure that it's not a negative number. So we'll go over here to the side and verify. So if I plug in -6, I end up with -1/6 minus, let's see, -6 plus 1 is -5. So that would be a -1/5. So it turns into plus 1/5. And that is going to be a positive. So -6 works just fine. We'll plug in 5. We get 1/5 minus 1 over 5 plus 1. And you'll notice that's actually the same thing. So that's also positive, and both are solutions. Right, and that is the end of our Objective 5 notes.